Hi everyone, I developed a gateway for low-power devices called CapiBridge. It combines the LoRa and ESP-NOW protocols, offering the best of both worlds. The goal was to unify all sensors using the JSON format, bringing DIY to a new level. 2 lucky subscribers will get a fully assembled PCB with antennas, absolutely free. To participate in the giveaway, just hit like, subscribe, and let us know in the comments which DIY sensor project you're excited to use it for. It all started when I decided to use the ESP-NOW protocol for my upcoming projects, such as solar-powered sensors that use supercapacitors instead of batteries. The ESP-NOW protocol promises energy efficiency, a good communication range, and many other appealing features. To check if this was true, I assembled the gateway on a breadboard, wrote some simple code, and was seriously surprised by the energy efficiency of the test sensor, which was simulated by my new ESP32 board and was able to send sensor data 3000 times while consuming virtually no power. More about this board in the following videos. Excited about the energy efficiency, I began to draw the future PCB schematic. I will say the hardware part is straightforward. 2 ESP modules are linked via UART, and a LoRa module connects through SPI. I've also added an automatic reset circuit to eliminate the need for button presses during firmware updates, sparing me the hassle and finger pain usually associated with manual resets. I strive to create step-by-step documentation and nice schematics for you guys. My private projects aren't as polished, so if you enjoy what you see, hitting the like and subscribe button would really help. The board was designed in such a way that it's possible to add an additional shield. Maybe in the future, we will add a 433 MHz receiver. For tinkerers, this brings the possibility to add sensors directly to the gateway. The PCB and the beautiful 3D printed case are provided by our sponsor, PCBWay. They offer PCB assembly, CNC milling, and 3D printing services with a variety of materials. Essentially everything you need for your next DIY project. All files for ordering PCBs and the 3D enclosure are available on GitHub, so give them a try.
One eternity later.
I think it turned out great, at least for me. I used 2 C3 modules. The first ESP is responsible for communication with the LoRa module and connection to Wi-Fi, while the second is for receiving ESP-NOW messages. There are several diagnostic LEDs that light up when receiving LoRa and ESP-NOW packets. 2 LEDs for ESP inner communication, and 2 classic LEDs that are connected to UART for programming. The switch allows you to toggle between ESP modules for alternate programming. On the back side, all GPIOs are labeled. On the second ESP, all outputs are free, while on the first, only a couple are available. Most importantly, do not connect the USB to the board, even just for programming if the antennas are not connected, as this could cause the module outputs to burn out. The back side of the enclosure is printed with PLA and features 5 holes for antenna cables, 3 on the top and 1 on each side. If the antennas operate on the same frequency, we need to space them as far apart as possible. For mounting the PCB and cover, I used 4 2mm brass inserts. The front cover is printed from clear resin just for the sake of the video, but you can also print it with PLA. I will make sure to have a couple of printed enclosures in stock in my shop. And yes, the backside of the enclosure is already designed to accommodate a future shield. You need to pay attention to the cables. They should not bend at sharp angles. It's best to form a loop. IPEX connectors are a bit fragile, so position them carefully and gently push them into place. Also, keep track of which cable is connected where. The cover bolts are M2, 12 mm in length. All links to the components can be found on GitHub. ESP-NOW and Wi-Fi use the same antennas because they operate on the 2.4 GHz band. For LoRa, however, it's a different story. You need the best antenna you can find. Even the most sensitive receiver won't perform well with a poor quality antenna. So let's check if the magic smoke stays inside the components or not. Already not bad. The first ESP's firmware consists of 2 files, and all configuration is done in the config.h file. You need to fill in the gateway key, which allows you to differentiate your data from others. Fill out the Wi-Fi and MQTT credentials and configure the LoRa settings. The range is impacted by the spreading factor. Increasing the range decreases the transmission speed, which can negatively impact on battery life. Therefore, don't increase the spreading factor more than you need for a 4-disc sensor. Now, you need to select the board. Choose ESP32 dev board, select Erase all flash before sketch upload, and then choose the COM port. If you don't find ESP dev board in the list, you need to install it. More about that on the GitHub page. Switch the CapiBridge UART to ESP1, then upload the sketch. After the upload, for diagnostic purposes, CapiBridge will print out any received JSON string so you can see if it is received by ESP-NOW or LoRa, and you can easily find any JSON formatted problems. ESP2 firmware doesn't require any configuration, just select the ESP2 and upload it. So, let's see how it works with Home Assistant, and then I'll do a range test to compare ESP-NOW with Wi-Fi. CapiBridge supports MQTT auto-discovery for many sensors. It chops up the JSON string and publishes values to the appropriate topics, with the specific topic determined by the JSON keys integrated into the sketch. Fully supported sensor entities can be found on GitHub, and new entities can be easily added. You can have as many sensor nodes as you like, just ensure each node has a unique name. The CapiBridge itself has only one diagnostic sensor, which is RSSI. To test the range, I place CapiBridge vertically on the table, somewhat close to the window, and I will go outside over there with the sensor. The distance was 140 meters or 153 yards. I have with me two ESP dev boards. One will try to connect to Wi-Fi, and the other will send ESP-NOW messages every 2 seconds. First, let's check the Wi-Fi one. If it manages to connect, it will publish the word Wi-Fi. Nope, it can't do it. Even my phone can't find my access point. But ESP-NOW is reaching the gateway, as you can see from the counts. Unfortunately, ESP-NOW doesn't support RSSI, so I can't tell how much range is left. It makes no sense to check the LoRa range again, since I've already done a range test for a mailbox sensor, which is my other project and is based on a LoRa module. The video link is in the description. I offer ready-made devices in my shop. Purchasing one supports the development of future projects. If you have any questions, please feel free to ask. I will do my best to help you. Thank you very much for watching. I hope you enjoyed the video, and until the next one.